In selection sort, we're going to loop over our unsorted array and select the smallest element and then move that to the beginning of the list. Then we're going to select our next smallest element and put it second in the list, and so on. And so to do this, we're going to maintain a couple pointers. We're going to keep a current min pointer. I'm going to use this red marker to denote what's currently the smallest thing we've seen in this loop. This I with a green marker is just going to show the boundary between our unsorted partition and our sorted partition. And then J will show that sort of inner loop. If you're thinking about nested loops, it'll show which element we're currently considering and comparing to see, is this my new smallest min? So when we begin, right, all of these pointers are at the same position. Our unsorted list begins right at the first index, since everything has got to be considered unsorted. And we're considering the element 3. So right now, 3 is the smallest thing we've seen, so we point to it as our min. We look at 24, that's no smaller. We look at 2, and we say, oh, that is actually the new current min. We keep marching along looking for anything smaller than 2, and we don't find it. And so at this point, we know 2 is the smallest element in the list. It's been selected, and we're going to swap it with whatever is at this green marker, our boundary between unsorted and sorted. So these two elements swap positions, and 2 is now in its sorted order. We know that's the smallest element in the list, and it's in the first position. So we increment this to go through our second iteration of the sorting algorithm, and we say, okay, at this point, 24 is our smallest element left, as far as we know. Then we look and we spot a 3, so we say, nope, that's the smallest element left. We look at 29, that's bigger than 3, so is 5, so is 43, so is 44. And so we know 3 is our next smallest element, so we're going to swap it into position based on this green marker. So we swap these two, and we mark 3 as in sorted order. We increment this, and now we say, all right, of the remaining elements, as far as I know, 24 is the smallest. Okay, we compare that to 29, and 24 remains still the smallest. Compared to 5, though, we see we found a new min. Compared to 43, no change. 44, no change. And so 5 must be the minimum element in our remaining elements. So we swap it with the 24 because that's in the green position. We continue this process. So we'll say, of the remaining elements, as far as I know, 29 is the smallest. Oh, just kidding, 24 is the smallest. That remains true, that remains true. And so 24 is getting swapped into position, since it's selected as our next smallest element. Of our remaining list at this point, 29 appears to be the smallest, confirmed with 43, confirmed with 44. So 29 is already in sorted order. We just move our partition marker one more increment. Again, we see 43, and we say that looks like the smallest thing left in the list. And compared to 44, that holds true. And at this point, we have a single element left in the unsorted partition, so it must be our largest element, so we can mark it as sorted. And now we've completed selection sort, and we can see that our list has found its sorted order.